Hello students, let us continue the MCQ series. Let us see question number 21. The number of millimoles obtained in 0.160 gram of NaOH. Now here they are asking about the solute NaOH. So first let us see what is the molecular weight or molar mass of NaOH. It is equal to, this is 23 plus 16 plus 1, that is 40 gram. So the molar mass of NaOH is 40 gram here. They are asking you for 0.160 gram of NaOH, but here millimoles are asked. So let us first convert that. You know that 1 mole is equal to 1 mole of any substance corresponds to 1000 millimoles. Right students? So what I can do is I can take 40 gram of NaOH means 1 mole. Now we want the answer in millimole, so therefore it is equal to 1000 millimole. Now instead going for mole, I will go for directly this concept. 40 gram corresponds to 1000 millimole. Therefore, for 0.160 gram, it will be how many millimoles? Let us cross multiply this. So that will be equal to 1000 multiplied by 0.160 divided by 40. If you calculate this student, you will get the answer as 4 millimoles. 4 millimoles. So answer is third option. See the next question. The number of moles present in 1 cubic meter of a gas at NTP is. Now student, you know that 22.4 liter or dm cube of any gas must be occupied by 1 mole of the substance. Now therefore, for 1 cubic meter means how many student? Corresponds to 1000 liter. This is the conversion. For 1000 liter, it will be how much? So it will be simple, 1000 multiplied by 1 divided by 22.4. What I did here, 1 cubic meter is equal to 1000 liter, means they are asking for 1000 liter. So your equation will be 22.4 liter corresponds to 1 mole. So for 1000 liter, it will correspond to how much? Simple cross multiplication. If you do this calculation, your answer is 44.64 gram. So your answer here is third option. See the next question, question number 23. Element A with atomic weight is given. The element B combines to form a new substance X. If 2 moles of B combine with 1 mole of A, then the weight of 1 mole of X will be. Students, here let us write a rough equation. They say that A when combines with B, compound X is formed. Right? A atomic mass is 12 and B atomic mass is 16. Means they give the ratio also of the moles. If 2 moles of B combine with 1 mole, means the ratio is 1:2. If the ratio is 1:2, so the compound X what is formed must be of AB2 type, because it will be A and B2. So the molecule will be of this type. So let us add this. This will be 12 plus this will be 16 into 2. So that is 12 plus 32. So the mass here will be 44 gram. Simple student, because if you see this mass, it relates to carbon. This is oxygen. So what type of compound here formed is might be of CO2 type, and the molar mass here is 44 gram. So the answer here is second option. See the next question, question number 24. The weight of 2.8 liter of a gas at NTP is 3.50 gram. Its vapor density. Students, this is a new concept of vapor density. So first let us understand what is vapor density. Vapor density is a way to calculate the molar mass of the substance. The formula is molecular weight of any substance is equal to 2 into vapor density. So this is the formula. Now what they are asking you here student, weight of 2.8 liter of a gas is given. So its vapor density will be. Now to calculate this, first I should know the molar mass of the substance. For molar mass, if I see the question, liter is given. So which standard equation I can use student? I can use that 2.8 liter of the gas. It weighs 3.50 gram. 2.8 liter weighs how much student? 3.50 gram. Therefore, 22.4 liter must correspond to its molar mass. This is our standard equation, right? So, what will be molar mass? Molar mass of the substance is equal to 3.50 multiplied by 22.4 divided by 2.8. If you solve this, you will get 28 gram. So this is the molar mass of the substance. Now molar mass I will substitute here. You know this value, you can calculate vapor density. So what it will be? 28 is equal to 2 into vapor density. So what is vapor density is equal to, student? It is equal to 14. So answer here is first option. Let's see the next question. The volume occupied by 7.23 into 10 raised to 23 molecules of carbon dioxide and 3 into 10 raised to 23 molecules of argon at 0 degree Celsius and 1 atm. Total volume they want. So to calculate the volume, we have the standard equation that if I get the number of moles and if I multiply that by standard value 22.4, I can get the total volume. So let us first calculate the number of moles. So first they have given for carbon dioxide. Carbon dioxide moles will be number of moles of carbon dioxide is equal to given volume divided by total number of molecules. They have given this molecule. What is our standard molecules? Avogadro number into 10 raised to 23. If you calculate this, it will come to 1.2. What I got this, student? This is mole. Right? Let us calculate the number of moles of carbon dioxide also. Here also they have given the molecules. So let us calculate the molecules again here. It will be 3.01 into 10 raised to 23 divided by again Avogadro number. If you see the relation, what you will get here, student? 0.5 moles. Let us calculate the total moles. Total mole is 1.2 of carbon dioxide here and 1.2 of argon here. Sorry, this is argon. Right? So it will be plus 0.5. How many total moles? 1.7. Right? 1 mole of any gas must occupy a volume of 22.4 dm cube. Therefore, the total moles, how many we got? 1.7. So 1.7 moles corresponds to how much? If you cross multiply this, you will get 38.08 liter. Why I got this in liter? Because this is in dm cube, right? But there is no option in liter. This option is not matching. So let us convert this to milliliter. So that is equal to 38.08 into 10 raised to 3 milliliter or 3.808 into 10 raised to 4 milliliter. So the answer here is third option. Students, please like the video if you find it interesting and please do subscribe my channel to get more such videos. We will be continuing the series with few more concepts like average atomic mass, limiting reagents, stoichiometric calculations. So please subscribe to my channel to get more such videos soon. Thank you, students.